Today we're going to be doing lesson 1.2, solving multi-step equations. Now, last week's lesson was solving simple equations, or what we could have called one-step equations. Does anybody know why we would have called those one-step equations? There was only one number keeping the variable from being alone, right? There was only one step to getting that variable by itself. Well, today we're going to look at multi-step. So it could be a 2-step, it could be a 3-step, it could be up to a 5-step problem. All right, and the essential question that we're going to answer by the end of the hour is, how can you use multi-step equations to solve real life problems, which is exactly what we answered in our first lesson. So we're going to see some real life situations where multi-step equations come into play. But I want you to think back for just a minute to elementary school when your teachers were teaching you the order of operations. Does anybody remember the sentence that they taught you to help you remember PEMDAS? Please
excuse my dear Aunt Sally.
Please excuse my dear Aunt Sally, okay? And while it never leaves you, I mean, even though you couldn't think of it right then, as soon as I said please, you were like, oh yeah, please excuse my dear Aunt Sally. Well, I have a sentence to help you remember multi-step equations, and here's why this is important. We are going to use this sentence all year long. We're going to get all the way to chapter 6 and 7 and 8, and you're still going to hear me refer to this sentence. So the first thing I want you to do in your notes is I want you to highlight the sentence at the top of the page. It says, don't call me after midnight. Don't call me after midnight. And of course, the first letter of each word is going to help you remember the steps to solving a multi-step equation. All right, so we're going to fill in those blanks and we're going to add a few extra things. The D in don't stands for the distributive property. Now, does anybody know, when you look at a problem, if the distributive property is there, what symbols do you see in the problem? Does anybody remember? What's a key clue to the distributive property?
Parentheses.
Parentheses, very good. So after you write in distributive property in your notes, I want you to just put a little set of parentheses beside it. If there are no parentheses in the problem, then there's no distributive property. So that's going to be a quick step that we're going to be able to decide on. The C in call stands for combine like terms. Now, it's very important that you understand, when we're combining like terms, we're talking about terms that are on the same side of the equation. So after you write combine like terms, I want you to add this little piece of information, on same side. So we're going to be looking at the left side of the equation to see if there's any like terms. Then we're going to go to the right side and we're going to see, are there any like terms that can be combined. But let's talk about like terms. All right, let's refresh our memory. If I were to give you 2x and x squared, are those considered like terms? No, they are not. Why are they not? Say it again. Okay, they both have an x in them, but one has an exponent of 2 and one of them has an exponent of what? What is this understood exponent right there? 1. Very good. So like terms have the same variable raised to the same power. These variables are the same, but they are not raised to the same power. So these are not like terms. But what if I gave you 2x and 4x? Are those like terms? Yes. Those we can combine because both have the same variable raised to the same power. All right, good. Now, moving on to me in the sentence, the M in me stands for move the variable. Now, this is key as well. You're only moving a variable if there is one on both sides of the equation. If there's only one variable in the entire problem, then we don't need to move the variable. But if there is a variable on both sides of the equation, we're going to do our best to move the variable to the left side of the problem. Remember my preference that I taught you last week? I like the variable in the final answer on the left side. So if we can go ahead and move it to the left side, then that's what we're going to do. Okay? If moving the variable to the left side left nothing else on that side of the equation, then we wouldn't do it. And we'll get to examples like that and we'll see things like that as we move along. But we're going to do our best. If we have to move a variable, we like to move it to the left side. Then we get to after. The A stands for add or subtract. If there is a number that needs to be moved away from the variable, and it can be moved with addition or subtraction, we're going to do that next. And that leaves our very last step, the M in midnight. We multiply or divide. So if there's a number that needs to be moved away from the variable with multiplication or division, we're going to do that last. Now, as we work through these problems, and I've given you quite a few problems in the notes to work through because I just want us to practice and keep using don't call me after midnight until it's ingrained in our brain. So let's look at example number 1, letter A. The distributive property, that's step number 1. Do we have the distributive property in letter A? No, there's no parentheses, so we know right away we're skipping that step. All right, call. The C stands for combine like terms. So look at the left side. Are there any like terms? Then look at the right side. Are there any like terms? So we skip that step. Do we need to move a variable? The third step is me, or move the variable. Do we have a variable on both sides of the equation? So we skip that step. So now we're at after, or add, or subtract. What is the variable that we are trying to isolate? N. Okay, so remember last week, let's do this in our notes. Don't have to do it in homework, quizzes, and tests, but we're doing it in our notes. We're trying to isolate N. How many numbers are keeping N from being alone? 2. And remember, the order in which we move them matters. If we don't move them in the right order, the answer will not come out right. So we're remembering after, so add or subtract. Which number can we move with addition or subtraction?
Addition. 3.
The 3. Does everyone agree with her? Okay, so how do we move it to the other side? We subtract 3 from both sides of the equation. So we cross that out. We bring down what we have not used, which is negative 2n, equals, what is 9 minus 3? 6. That brings us to midnight, or M, multiply or divide. What number do we need to move by multiplication or division? We're going to divide both sides by negative 2. Good. Don't forget, when you multiply or divide, you keep the sign. So N equals negative 3. Beautiful. Box it in. Remember, equations can be checked. So if you want to check your answer, you can always go plug it back into your original problem. All right, let's move right along to letter B. Distribute. Do we have to distribute anything? Yes or no? Everybody should be able to tell me that. So no, there's no parentheses, so we keep moving. Combining like terms. Do we have any like terms to combine? No. Okay, there's no like terms on the left and no like terms on the right. Moving a variable. Do we need to move a variable? Yes. Now be careful. We only move a variable if there's a variable on both sides of the equation. So we're not moving a variable. So again, we're at adding or subtracting. What variable are we trying to isolate? Good. So what are we going to move first? We've got to add or subtract. So you got to pick the right number. Which number can we move with addition or subtraction? But hold on, Jack, negative 21 is all by, it's not keeping C from being alone, so we're not moving it. Cam, what'd you say?
11.
11. And how are we going to move it to the other side? We're going to add it. Very good. So what we do to one side, we're going to do the other. What is negative 21 plus 11? Be careful. Every number has a sign. The sign's directly in front of it. Good. Signs are different. So we subtract. We get 10. 21 is larger. We take the negative sign. And we bring down the 1/2 C. Now, we still are trying to get C by itself. So what is the last thing that we need to move with either multiplication or division? 1/2. Now, we learned a shortcut. Remember last week when we're trying to move a fraction that has been multiplied by the variable, what is the shortcut to move that fraction? The reciprocal. But what are we doing with that reciprocal on both sides? Well, that we've already, the reciprocal is switching, but what are we doing with it on both sides? We're multiplying. All right, we're multiplying. So what is the reciprocal of 1/2? 2. Do we have to have the 2 over 1? No. You can if you want, but you don't have to. Now, we learned last week that a fraction times its reciprocal equals 1. So that's why I went ahead and canceled on the right, leaving me with just the equals c. And what is 2 times negative 10? Negative 20. Now remember, I prefer the variable first, so we're just rewriting the final answer before we box it in. All right, look at letter C. You tell me, what is the D? What does the D and don't stand for? What's the first step? Distribute. Do we have the distributive property in letter C? No. So then we move to call. What's the C in call stand for? All right. Do we have like terms that we can combine? Yes. What are they?
Negative 2 and negative 10.
All right. Give me the whole term, though.
Negative 2x and negative 10x.
Good. Negative 2x and negative 10x. So when we combine those, what do we get? Now, let's refresh again. We have numbers or coefficients, and we have the variable. What part of the terms are we actually combining? Are we combining the numbers, the coefficients, or are we combining the variables and getting x squared? That's what I'm trying to get you to remember. Just the coefficients, just the numbers. So negative 2 minus 10 is what? Careful. Right, every number has a sign, the sign's directly in front of it. That's a negative 2 and a negative 10, which combined gives you negative 12, and the variable does not change. It stays the same. Then we bring down what we have not used, all right? We're at me. What's the M in me stand for? All right, do we have a variable to move this time? No, we do not have a variable on both sides of the equation, so we skip that step. After. What's the A stand for? Do we have a number we can move with addition or subtraction? Yes, because we're trying to isolate x, so what are we going to move? The positive 12, the plus 12, and how do we move it? We subtract it from both sides. So we bring down the negative 12x, and it equals, what's 18 minus 12? 6. All right, midnight. What's the M in midnight stand for? Do we have a number we can move with multiplication or division? We can divide both sides by negative 12. Now, this brings us to something that is important. And if you want to write this in your notes so you don't forget it, you can. I do not want decimal answers unless the original problem started with a decimal in it. Now, be careful on Big Ideas Math, because if it tells you to round to the nearest tenth, then it does obviously want a decimal answer. I don't think it does it that often, but I want you to know for quizzes and tests, I don't want a decimal answer if the original problem did not start with a decimal. I want fractions. I actually am even okay with improper fractions. If your fraction comes out to be improper, leave it improper. But what is the one thing that we have to do to all fractions? We have to simplify them. So you must always simplify the fraction, but leave it as a fraction, leave it as an improper fraction, just make sure it's reduced. So does this fraction reduce? 6/12. Yes. Because what number goes into both 6 and 12? 6. So it reduces to what? 1. Careful. Negative 1/2. Now that negative can go in front of the fraction. It can go up beside the 1, down beside the 2. I don't care as long as it is there. But x equals negative 1/2 is your final answer. All right, let's look at letter D. Let's start with step number 1. Don't. What's the D stand for? Do we have the distributive property? Yes. What number are we distributing in this problem? 3. All right. So right here, I want you to underline. You say, how do you know you're distributing? Because, well, first of all, there's parentheses, so that's a really good clue. But sitting right here outside the parenthesis is a number waiting to be multiplied by everything on the inside. You say, how do you know it's multiplication? What is between the 3 and the parenthesis? Anything? No. There's no sign between the 3 and the parenthesis, so that is multiplication. Now, again, we're doing this part in our notes just so it's there because we haven't done this in a while. When we distribute the 3, we're multiplying it by every term on the inside. So what is 3 times x? 3x. And what is 3 times 1? Positive 3. Then we bring down what we have not used. All right, call. What's the C stand for? Do we have like terms to combine? Yes, what are they?
3 and 6.
Good. Remember, like terms have the same variable raised to the same power. So if neither of these terms have a variable, then they're alike. So we bring down the 3x. What is 3 plus 6? 9. And it equals negative 9. Me. What's the M stand for? Do we have a variable to move? Nope. After. Add or subtract. Can we move a number with addition or subtraction? All right, we're trying to solve for x, so we're going to subtract 9. So 3x equals, what's negative 9 minus 9? Careful. Negative 18. Add and keep. Signs are the same. Add and keep. Then to finish off this problem, midnight. What's the M stand for? What are we doing? Dividing both sides by 3. So x equals, what's negative 18 divided by 3? Negative 6. A negative divided by a positive is a negative. Now let's keep moving, and we're gonna push through these pretty quick because it's just more of the same. But I just want to get "Don't Call Me After Midnight" in your brains. All right? Are we distributing in letter E? Yes. What are we distributing? Right here.
4.
Remember, parentheses should trigger you to say distributive property. There is a 4. It is sitting outside the parentheses waiting to be multiplied. So 15 equals 5. What is 4 times 2D? Okay, positive 8D. And what's 4 times negative 3? Negative 12. All right. Combining like terms. Do we have any? Yeah, what are they? Good. So 15 equals, I'm going to bring down the 8D. What is 5 minus 12? Negative 7. Do we have to move a variable? No. Do we have anything to add or subtract? Yep. What are we adding or subtracting? 7 to both sides. What's 15 plus 7? And it equals 8D. And do we have anything to multiply or divide? Yes. What are we dividing both sides by? 8. Now, I'm going to go ahead and put D equals because I know I'm going to switch it anyways. But is there anything I can do to 22/8? It's improper, and remember, I'm okay with that. Leave it improper, but we got to simplify it. Okay, 11 over 4. 2 goes into 22 11 times, and 2 goes into 8 4 times. So your final answer is 11/4. Remember, leave it improper, but reduce it. Always reduce it. All right, look at letter F. Distributive property in this one? Combining like terms. What are they?
9 and negative 6.
All right, so we have negative 12 equals, what's 9x minus 6x? 3x. Bring down what we have not used. Do we need to move a variable?
No.
All right, Odina, what are we doing next? What are we moving next? Good. We're adding or subtracting, so we're subtracting the 15. What's negative 12 minus 15? Anyone? It's negative 27. And then I brought down what I had not used, which was the equals 3x. And how do we finish off this problem? Divide both sides by what? 3? No, never the x. We don't move the x. We just divide by the coefficient. And what does x equal? Negative 9. Again, you can see that I went ahead and switched it when I wrote my final answer. All right, letter G. What's the first thing we're going to do on letter G? Think through your steps on your own and tell me the first thing we're going to do. I heard it. Distribute, okay? D and don't means distribute, and absolutely. How many things are we distributing in letter G? 2. We're going to distribute here, and we're going to distribute here. So, Jordan, what do we get when we distribute the 5?
15.
Keep going.
15 and 5x.
All right, but what kind of 5x?
Negative 5x.
minus 5x or negative 5x. Good. Cameron, when we distribute the 2, what do we get? Good. We get a positive 6 because 2 times 3 is plus 6 minus 2x. All right. What's the next step we're going to do? We've distributed. Now we're going to do what? Combine like terms. All right. What are my like terms this time? I heard negative 5x, negative 2x. Any other like terms we can combine? 15 and 6. So negative 5x minus 2x is what? I gave it to you already. Sorry. Signs are the same. So what do we do when signs are the same? No. Add and keep. So when we add and keep, what do we get? Careful. Negative 7x. What's 15 plus 6? Positive or negative? Positive 21. Again, add and keep. All right. What's our next step? Add or subtract. So what are we adding or subtracting? All right, which one are we doing? Adding it or subtracting it? We're subtracting it because remember, we're trying to get x by itself. So what is 14 minus 21? Negative 7. And how do we finish off this problem? How do you finish it, though? Don't give me the answer. How do you divide both sides by 7? So what does x equal? What's negative 7 divided by negative 7?
Negative 1.
Careful.
1.
X equals positive 1. You've just divided a negative by a positive, so x equals positive 1. Which step are we starting on letter H? We're thinking through don't call me after midnight, so which of those steps do we pick up on? Add or subtract. There's no distributive property, there's no like terms to combine, and there's no moving of a variable. So we go all the way down to add or subtract. What are we adding or subtracting? 3. Are we adding it or subtracting it? We're adding 3 to both sides. So we have 15 equals z divided by negative 4. Emma, what are we doing to get z by itself? We're multiplying both sides by negative 4. So they cancel on that side, and z equals, oh, I have 15, guys. Did anyone notice I multiplied? There we go. Because 5 plus 3 is actually 8, and negative 4 times 8 is negative 32. Awesome job. All right. Now, like with any good math problem, there's always a shortcut. Not always, but a lot of times there's a shortcut. So look at this problem. If I ask you the first step that we're going to do to letter I, what's the very first step that we are having to do here? Distribute. Now, this should be, yours should say minus 3 on your paper. I'm pretty sure it does. What are they asking us to distribute? What kind of a number? A fraction. Is there anyone that loves fractions so much that you would like to distribute and have a bunch of fractions in your problem? Okay, that's what I thought. So that is why there is a shortcut that I'm going to teach you. Go ahead and fill in any blanks I left, and then I want you to actually highlight the shortcut. Look at what it says. When the number needing to be distributed is a fraction, you multiply both sides by the reciprocal first. So we have seen something like this before, right? If we want to get rid of a fraction quickly, we are going to multiply both sides by the reciprocal. So looking at letter I, what is the fraction that they've asked us to distribute? Negative 6/5. So we are going to multiply both sides by the reciprocal instead of distributing it. What is the reciprocal? Okay, be careful. Okay, the negative's got to go somewhere. I don't care where it goes, but it's got to go with either the 5 or the 6. But we multiply both sides by the reciprocal. We already know that a reciprocal times itself equals 1, so we can cancel out on the right and just bring down x minus 3. Now, remember, 66 can be put over what number? It's a whole number, so we can put it over 1. Now, can we simplify before we multiply? What will simplify? 6 and 66. What goes into 6 and 66? 6. 6 goes into itself once, and 6 goes into 66 11 times. So when you multiply what's left on the left, what do you get? Negative 55. Now, there's only one step left here. How do we get x by itself?
Divide by, oh wait. Add 3.
Add 3 to both sides. So do you see how quickly we're able to finish this when we get rid of the fraction instead of distributing it? So x equals, what's negative 55 plus 3?
Negative 52.
Negative 52. And of course, we want the variable first, so x equals negative 52 is what we're going to box in. Beautiful. All right, do letter J on your own. Jordan, what's the number they're asking us to distribute this time?
3 over 10.
So instead of distributing it, what are we going to do?
Yeah, multiply both sides by the reciprocal.
Which is?
10 over 3.
Very good. So we're going to multiply both sides by 10 over 3, which of course will cancel on the right and leave us with x plus 2. And Jordan, were you able to simplify before you multiplied on the left?
I was in the middle of that. It was the 4 over. I had it 4 because 12 divided by 3.
Okay, so the 12 and the 3 simplify, right?
Yeah.
So the 3 goes into itself once, and the 3 goes into the 12 4 times, which leaves you with what?
4 over 1, right?
Not 4 over 1.
Just 4.
Oh, you got the 10 times 4 up there. Remember your reciprocal was 10 over 3, so you still have 10 in the numerator. So what's
44 or 40?
40, good. All right, and then the only thing left to do to get x by itself, anybody? Subtract 2 from both sides. So x equals 38. And of course we want the variable first. So x equals 38. Now that brings us to real life situations. How can we use a multi-step equation in a real life situation? And remember what I taught you last week. When you are given a word problem, if the equation that you create or the problem that you create does not look like what you've been working on in that lesson, that's a good indicator that you've done something wrong. All right, so let's be very careful, but let's underline and circle some important information in this problem. It says you spent $50 on supplies. Now guys, if you spend money, are you gaining money or are you losing money? Losing. So if I see spent, I know that that's going to be subtraction at some point. I spent $50 on supplies for the bake sale. Each item sold for $2. Now, this is another key word right here, each. Anytime you see the word each, an operation should come to your mind. What operation, when you think about each, do you think addition, subtraction, multiplication, or division? If I buy a hair bow for $5 each, okay, let's say I buy 3 hair bows and they're $5 each. What am I doing with 3 and 5? I'm multiplying. Very good, very good. So when I see each, I am thinking multiplication. Now it says each item sold for $2. So there's another number. Now after the sale, you had a profit of $180. How many items did you sell? So there's the word items again, which means items becomes our what? If that's what we're looking for, what's it going to be in the equation? The variable, the unknown. All right, now we already said if you spend $50, that's minus $50. So I'm going to go ahead and write minus 50. The question is, what am I subtracting 50 from? Well, this says I sold each item for $2. So isn't that where I'm making my money, the items that I sold? So what am I doing with the 2 and the x? If each item sells for $2, what am I doing with the 2 and the x? All right, I'm combining them, but how? Am I adding them, subtracting them, multiplying them, or dividing them? We already said each means multiply, so 2 times x. That's where our money is coming from. As we sell an item, we're making $2. When all is said and done, we have a profit that equals how much?
180.
Now, does this look like a problem we've been solving?
Yeah.
Yes, so let's solve it. How do we get x by itself?
Add 50.
We're going to add 50 to both sides. So 2x equals 230. How are we going to solve for x?
2x divided by 2.
Divide both sides by 2. So how many items did we sell? 115. Now, this is a word problem, so what is the label we're putting on it? Items. Very good, because that is what we were looking for. Now, letter B is more of a sentence that we're going to turn into an equation and solve, and not a word problem. But let's read it. 8 plus, right off the bat, I can go ahead and write down 8 plus. 8 plus the quotient of. Now, when you see the quotient of, what type of problem are we talking about? The quotient is the answer to division. So go ahead and put your little division bar. What are we dividing? It says the quotient of a number and 3. So what's my numerator? Okay, a number can be replaced with a variable. And of course, a number and 3 makes 3 my denominator. And here's that little word is. What symbol goes in the equation? When we see is, it equals, what does it equal? -2. Does this look like an equation we've been solving? Beautiful. So let's solve it. What do we do first? Subtract 8 from both sides. X divided by 3 equals, what's -2 minus 8? Anybody? -2 minus 8? -10. Remember, signs are the same, so we add and keep. And then how do we get x by itself? What is it, Jack? Good. Multiply both sides by what? We're going to multiply both sides by 3 because they were dividing by 3. So x equals? -30. Now, does this one need a label? This one does not need a label because it was not technically a word problem. It was a sentence that we turned into an equation. That is lesson 1.2.